you. Good afternoon, everyone. And my great pleasure to be here and to tell you more about DataVisor and broadly about what I've been working on like for decades, starting from like graduate school, moving into industry, Microsoft Research, Silicon Valley, and then continue to pursue in my startup job. And we've heard about talks about like real criminals solving some of the puzzles of forensic analysis. So what I want to talk about today is more about cyber fraud, cyber crimes, and things going on online. And so a brief introduction about DataVisor. So DataVisor is a company that we started in December 2013. So we've been there for over 5 years. And we're a post-C series company led by Yinglian Xie. And currently, our headquarter base is in Mountain View, but we also have offices in Beijing, Shanghai, Singapore, and have a team in New York and Korea. And so we particularly focusing on detecting variety of fraud, abuse, and money laundering problems for large consumer-facing enterprises. And so we've been protecting globally over 4 billion accounts today. And just think about like sort of the scale of the data that and the number of users we've been protecting, and we feel a very satisfying and very kind of fulfilling job to help all these large online services restore trust and protect everyone. And the company is co-founded by two like female founders. And interesting maybe to the topic here. So yes, we can all make it happen. And so I'm lucky to be working with Fang Yu, my co-founder, and while we were Microsoft, we were colleagues for the 7.5 years we were there, and we started this company together. So what I want to talk about today is, first I want to talk about a little bit what attacks we are facing, what are some of the problems we are solving, and how it's evolving. And I want to talk about the technologies that we've been seeing, in particular focusing on, and in this kind of cyber criminal scenario, and some of the newest kind of machine learning technology that in particular the unsupervised approach that we're focusing on of solving the problem and why we need such approaches. And some of other thoughts as well regarding where we are moving into for the next kind of generation of fraud detection. And finally, it was asked to provide a little bit kind of my thoughts and tips regarding starting a company of your own. And I'm happy to share a couple of my thoughts as well. So first of all, what are problems we're solving? So we all know like we are moving online rapidly for pretty much everything. From in the past kind of the social commerce side toward now traditional business as well. For example, like sort of insurance, healthcare, everything's moving online. When things move online, actually the attack and the fraud we see is significantly different than in the past. In the past, somebody wants to create a fraudulent bank account. They need to walk into a bank branch, and they need to be physically there. And today, they just need to have an identity, whether it's synthetic identity or it's a stolen identity, and they can create accounts without our awareness. So the type of fraud is significantly easier than in the past. And what's more, attackers have been using very sophisticated techniques. And at the same time, we all know when services are moving online, they hope to bring a very rich experience to us. So they keep adding new features and new channel service. But unfortunately, each new feature, each new function just introduces a new way of being vulnerable and being inviting on new type of attacks. Here are some examples of fraud and abuse types, and we wonder what exactly are they. The familiar type, that sometimes our accounts are taken over, like a compromise. And we mentioned like credit card application fraud. We all know like there are a lot of data leakage happening everywhere. When our data is leaked, what are these used for? Attackers are actively using our, for example, name, address, our credit card information, as well as social security. These information, they can open, for example, like apply a credit card, and without us even knowing about it, or they have a bank accounts, etc. And not to mention, we all have the common type of, for example, chargebacks we see, and somebody get our like sort of credit card number, they can abuse it. But there are also other types of fraud. We sometimes heard about them as well, like buyer-seller collusions, fraudulent insurance claims, and fake reviews, and even fake listings when you go online and you want to go like search for products. And many marketplaces are fighting against problems where the sellers are fake. Not just like buyers can be fake, but the sellers are selling goods that just do not exist. So by looking at analyzing like sort of the fraud, like the type of attacks that we've seen, like DataVisor published this quarterly fraud index report on a regular basis. So I used the data point that from July to September last year to talk about some of the attack trends we've seen. During that quarter alone, we've analyzed over 42 billion of events crossing like around 750 million online users and accounts. And we are yet to publish a newer version talking about the attacks we've seen in December coming up really soon. So the first trend we've seen actually from our quarterly report that in the past, we always talk about the interesting trend we see the attackers are also leveraging advanced technology like cloud computing as well. They've been actively using data center IP addresses. But what's kind of new to this particular like fraud index report that during that quarter, what do we find a new trend is attackers not only like use data centers, but they started actively using these residential VPN accesses to hide their true origin of network access. And the statistic in the past, we see that for those cloud-like data centers in the past, we can see as high as 18% of traffic of them being completely like fraudulent. And that's kind of the degree of them being abused by attackers. Nowadays, we saw that reduce for that quarter, like about 4 to 5%. But on the other side, the use of residential VPNs significantly increased. The second interesting thing that we see significantly increased use of customer throwaway email domains. And we know popular emails such as Gmails, like Yahoo, those are common targets of attackers. They remain popular. But the new trend we've seen is that we see these throwaway emails where like users could just register some address and go use those for signing up for sometimes newsletters. You don't want to give out your own kind of maybe email address that are being abused. We also have seen like those customized, like so custom domains. And in this example, if you see highlight, that particular domain was newly created, like compared to the July like time frame we are analyzing. And what's interesting, if you see that there are 40,000 other sites being hosted on the same server of that particular domain being actively used by attackers. The third trend we've seen is that in the past, attackers often try to like sort of mimic their attacks so that the attacks come from legitimate looking devices, but actually they don't exist. So a common technique they like to use in the past is called emulators. On the left side is basically a virtual device that emulated to be there. But nowadays, that doesn't work well anymore because defense techniques are rapidly evolving. There are many ways to recognize these as simulators or emulators. So nowadays, what you see more commonly is those like USB controlled device farm. Those are actual devices recycled by the attackers, have lots of them, so that it's difficult to detect, to say these are fake devices because they actually exist, and in particular those old versions of phones. So from the statistics, putting everything together, We roughly see about 65% of IP addresses and 43% of those devices and 52% of email domains actually rapidly being recycled, used for 7 days or less. That made it very difficult to basically detect attacks based on reputation scores, blacklists, etc. And unfortunately, legitimate users also actually are of a long-tail distribution, and many of them actually also show like sort of a short user cycle of some of these patterns as well. So putting everything together, what you would commonly see, that's from, for example, a large attack campaign of the top 10 social network that we've been working with. Everything look legitimate traffic, but this is a huge attack campaign. And putting everything there, we see they actually seemingly come from different IP addresses, but actually all these IP addresses are residential kind of VPN ones. And we also see many of their emails come from, we talk about these throwaway domains, as well as, for example, their devices show certain features that link them to like these, basically the old versions of certain phones being recycled. So coming back to fraud detection, how do we deal with these more sophisticated, like evolving attacks? And in the past, the most straightforward approach is to know what the good users look like and what bad users look like, and then to write rules. That's a common approach everybody uses widely. But soon we realize as a data science, we just say it's very difficult and time-consuming to write rules. You have to know what the attackers look like. And at the same time, the rules complexity continue to grow significantly, and at some large organizations in peak time, they could have over 10,000 rules. That's just not easy to manage. So supervised machine learning come to rescue. It says you don't have to know really what the attackers really look like. We just need the labels. Let us know what the good user, who the good users are, and let us have labels about what bad users are. And then let's automatically train a model. That idea sounds very appealing. The algorithms are very powerful. But the most difficult part regarding this approach is that for cyber fraud scenarios, we are faced with active adversaries. That means they are constantly changing as well. Many times, they test our models and make sure they can bypass before they launch attacks. So it's difficult, basically, to train a model that could detect, stay ahead of those attackers. When we have a model that requires like months of tuning time, that means we are capable of detecting attacks happened months ago, not attacks today or not attacks in future. So I want to talk about the unsupervised approach. The unsupervised approach then is attractive. What it means, we don't need any labels. We just have the data. Then it's our job to figure out what are the good users and what are the bad users. That sounds attractive, but how do we do it? We have also very high requirements as well. And for large enterprises, faced with analyzing events from hundreds of millions of users, and with no assumptions what attacks can look like. And furthermore, we know like sort of we have high real-time, like high QPS requirements when we have high like sort of traffic. We want to predict attacks in real time so that we can stop them earlier. And based on what I've talked about the trends, I hope we all get to like sort of figure out like this one like subtle thing that could help us is that these attack techniques also have some commonality. When they evolve at the time, they all try to do like sort of common, similar approaches and targeting similar vulnerabilities. And furthermore, to make the fraud economies work, they need a lot of accounts at the same time because one of accounts are outliers that are difficult to make profit as we face these modern, like sort of professional attackers. So what essentially we face are the attackers that come in like with a common goal, and they mix with good users. So the unsupervised approach, the goal is really to be able to identify these what we call fraud rings or attack campaigns from this massive like data by looking not just at individual user level, individual events level, but be able to analyze all the events, all the users together and be able to kind of, we call like cluster and identify these correlated patterns. And that's the essence of this unsupervised machine learning. And we know like legitimate users, we're like random variables. Our activity is controlled by ourselves, yet attackers are not. So if we have a lot of dimensions of activities, we have a broader view, we were able to then analyze them to identify the subtle patterns, like correlating these bad accounts together. So that's the essence and idea of this unsupervised machine learning, and that's what DataVisor has been working for, like to make it production quality at extremely large scale for the largest enterprises in the world. So moving on, looking like further, we're looking at basically not just the analytics approach in the server, and we also want to actively use our device to help us as well with the edge computing capability. And when our cell phones and devices become more powerful, to have a loop of working with the big analytics platform together to actively make it a more bulletproof system. And finally, I really want to talk about user experience is key when we security putting on a lot of like barriers for good users. Many times we really frustrated ourselves. Our experience is being impacted. And where legitimate users have a hard time logging in and really want to come to a world where we call it, like we advocate this zero-factor authentication, where we're going toward the direction multi-factor authentication. Can we do something zero-factor authentication? And the key behind this is on the surface, we have zero-factor authentication, but the server side, can we use data science? Can we use some of the ideas of supervised, unsupervised approach to have continuous re-authentications in the background to analyzing, yet legitimate users does not need to be impacted or do anything to prove we are good users. So I just want to quickly show the anti-fraud platform that DataVisor is building and taking variety of different kind of a client input and then putting the kind of the modern technologies together, combining the supervised machine learning technology and with the unsupervised machine learning like approach we talk about, as well as some of the conventional like solutions to solve a variety of different machine learning, different variety of these fraud detection problems. And as we have more and more data, and as we can see, our fraud index report and some of these common patterns can provide more intelligence to us, which we call like DataVisor's global intelligence network, and where we become smarter as well to derive like more like features, more signals, like benefiting from everyone. So finally, I want to touch upon like very quickly about like launching our own startup. I think in this case, in my case, I only want to focus on the two, which I've been like sort of mentioning at the beginning, sharing that have an idea that you're truly passionate about. And in my own experience, being working on this cybersecurity, cyber fraud detection, ever since I was a graduate student. So my thesis work is on network security. Then I moved to Microsoft to keep working on application level security of various types. And DataVisor, we really committed to bring this kind of fraud detection to the next level. Startup is a very long journey. And it's also like sort of have ups and downs. And when you work on something you truly love and are passionate about, you don't feel it's difficult or hard because you're working on something you enjoy on a daily basis, and I truly believe this is important. And of course, like being a startup, coming from academia, the biggest thing I understand is it's a business as well. To come up with the business model, to think about why you can do better than others as well. And while success is unique, you can also learn from many others' mistakes. So having some mentors or learning from others' startup experience is helpful as well. And finally, I want to talk about have a great partner. Like in my case, I was lucky to have another female kind of entrepreneurs who share similar interests and similar background, and we've been working together for a long time. And I think that's really kind of, I feel very lucky and very thankful to my co-founder Fang as well. And I think that's pretty much all to share with everyone, and thank you. Yeah.
Thank you so much. Wonderful.